one after the other አንደኛው ካፓሲተር ከሌላኛው ካፓሲተር በመቀጠል ኮምባይን የሚሆን ከሆነ ታይፕስ ኦፍ ኮምቢኔሽን ምን ሊሆን ይችላል ማለት ነው ሲሪየስ ኮምቢኔሽን ይሆናል ማለት ነው ፓራለል ኮምቢኔሽን የምንለው ደግሞ ካፓሲተራችን ኮምባይን የሚሆነው ፌስ ቱ ፌስ ከሆነ ነው here it possible that capacitors are combined or it's possible that connected face to face combinationaችን ምን ይሆናል face to face ይሆናል ማለት ነው face to face combination ከሆነ parallel one after the other ከሆነ ደግሞ series ይሆናል ማለት ነው so what does mean one after the other combination or connection when the capacitors are combining one after the other say types of combination is said to be series it means that let's consider this one is a wire so the first capacitor መጀመሪያው capacitor ሁለተኛው አሁን ተመልከቱ በአንድ ዋየር ላይ የሁሉ ካፓሲተሮች ምን ሊሆን ይመጣሉ ኮምባይንድ ሊሆን ይመጣሉ ማለት ነው ይሄ ኮምቢኔሽን ምን ይሆናል ማለት ነው seems like series ይሆናል ማለት ነው እዚህ ጋር ሶርሳችንን እናስቀምጥ ኤሌክትሪክ ፖቴንሻል የምንለው ነው ባትሪ ጄኔሬተር ዲናሞ ሊሆን ይችላል ሶርሳችን በእንደዚህ አይነት መልኩ እዚህ ጋር ይቀመጣል which is labeled by V is stand for electric potential ስለዚህ እዚህ ጋር ያለን ፖዚቲቭ ተርሚናል ነው እዚህ ጋር የሚኖረን ኔጌቲቭ ተርሚናል ነው ለክ በዚህ ጋር ኤሌክትሪክ ከረንት ፍሰት የሚያከናውነው ሃይ ኤሌክትሪክ ፖቴንሻል ዞን ሃይ ኤሌክትሪክ ፖቴንሻል ዞን እንለዋለን ሃይ ኤሌክትሪክ ፖቴንሻል ዞን ኤሌክትሪክ ፖቴንሻል ዞን እንለዋለን ኔጌቲቭ ተርሚናላችን ደግሞ ሎው ኤሌክትሪክ potential zone እንለዋለን ስለዚህ ከዚህ አንድ የምትረዱት ነገር ምንድነው ኤሌክትሪክ ከረንት ፍሰት የሚያከናውነው ከፍተኛ ግፊት ካለበት ወደ ዝቅተኛ ነው ማለት ነው ወይንም ከፖዚቲቭ ተርሚናል ወደ ኔጌቲቭ ተርሚናል ፍሰትን ያከናውናል ማለት ነው እንም በተለያየ ሌላ ቪዲዮዎች ላይ መገናኘትና በነምበር አይተን አራራላችኋለሁ ስለ ኤሌክትሪክ ፖቴንሻል so let's labeled by C1 C2 C3 C4 C5 so in this combination C1 C2 C3 C4 C5 are combined or connected face to face the types of combination is said to be series because they are combining one after the others አንዱ ከአንዱ ቀጥሎ combined የሚሆንበት ሲስተም ስላለ እዚህ ጋር C1 C2 C3 C4 C5 ኮምቢኔሽናቸው one after the other ነው አንዱ ከአንዱ ቀጥሎ ያ ኮኔክትድ የሚሆንበት ሲስተም ስለሆነ ስለዚህ C1 C2 C3 C4 እና C5 ኮኔክትድ የሆኑት በሲሪየስ ነው ብለን በቀላሉ ማስላት እንችላለን ማለት ነው እሺ ፓራለል ሲሆንስ ማየት ኮምቢኔሽን ነው ምክንያቱም ኮምቢኔሽኑ ፌስ ቱ ፌስ ካል ለምሳሌ ይሄንን ኮምቢኔሽን ወይንም ደግሞ ይሄንን ሰርኪዩት እንመልከት ሎካት the circuit is labeled like this so it is possible labeled by here have the source of electric potential so C1 C2 C3 this is the way how an electric current is flows through the circuits so here አሁን በዚህ ጋር በተመሳሳይ መልኩ C1 C2 C3 combined የሆኑት በፓራል ነው ፌስ ቱ ፌስ ነው የተለያየ ዋየር ላይ ያሉት ሎካት ስለዚህ በዚህ ኤክስፕሬሽን ውስጥ አንድ በጣም ማስተዋል ያለባችሁ መረዳት ያለባችሁ ኮምቢኔሽናችን ይህ ለምሳሌ ይሄንን ዋየር እዚህ አካባቢ ካት ዳውን ብታረጉት ስለዚህ አንድ ዋየር ላይ ብዙ ካፓሲተሮችን የምታገኙ ከሆነ ያ ኮምቢኔሽን ሲሪየስ ይሆናል ማለት ነው ስለዚህ በቀላሉ በዛ አይነት መልኩ መረዳት ትችላላችሁ ማለት ነው so the principle is said to be one wire for what for many capacitors አንድን የኤሌክትሪክ ሽቦ ለብዙ ካፓሲተሮች የምንጠቀም ከሆነ ያ ኮምቢኔሽን ሁሌም ሲሪየስ ይሆናል ማለት ነው so the other one is one wire only for one capacitor parallel combination ከሆነ ደግሞ ሁሌም የምንጠቀመው አንድን ዋየር ለአንድ ካፓሲተር ብቻ ይሆናል ማለት ነው So በዚህ ዲስክሪፕሽን ውስጥ መረዳት የምትችሉት አንደኛ ኮምቢኔሽናችን ሲሪየስ በሚሆንበት ጊዜ when the combination are C1 C2 C3 are combining in series always the charge that is accumulated or stored in each capacitor is the same. So it means that charge is constant. Electric charge is constant. ስለዚህ ምን ይሆናል? Q total which is equals to Q1 plus Q1 which is equals to Q2 which is equals to Q3 እያል መቀጠል እንችላለን ማለት ነው። በዚህኛው ዲስክሪፕሽን ውስጥ ደግሞ እያንዳንዱ ካፓሲተር ውስጥ ድሮፕድ የሆነ የሚያልፈው ወይም ስቶርድ የሚሆነ ወይም ድሮፕድ የሚሆነ ኤሌክትሪክ ፖቴንሻል መጠን ተመሳሳይ ነው። So electric potential is constant. Electric potential is constant. What does it mean? It means that V total is equals to V1 which is equals to V2 which is equals to V3 በዚህ አይነት መልኩ ኢኩዌት ማድረግ እንችላለን ማለት ነው። So let's see identically የነጣጠል ሁሉንም ኮምቢኔሽኖች capacitors in series. So ኮምቢኔሽናችን ውስጥ እስቲ ይሄንን ካፓሲተር እንስራ። Some types of combination are existed. So this is the source. So let's say that this one is V, the positive terminal, the negative terminal of our source is labeled. So here let's say that C1, C2, C3, C4. So let's contain all of these capacitors are combining in series. So in case possible that the total charge is equals to Q1 which is equals to Q2 which is equals to Q3 which is equals to Q4. If possible that constant. Charge ምን ይሆናል? constant ይሆናል። But the electric potential V total which is equals to V1 plus V2 plus V3 plus V4 vary ያደርጋል ማለት ነው። Capacitance of capacitoraችን ለማግኘት we can use the formula the capacitance, but it is possible that the capacitance of capacitor is equals to stored charge over electric potential. ስለዚህ እዚህ ጋር ምን ማለት እንችላለን? C total which is equals to Q total over what? V total ማለት እንችላለን። Let's find the value of V. So from this description the total electric potential is equals to, it seems like total electric charge divided by the total capacitance of capacitor ይሆናል ማለት ነው። Then using this description ይሄንን description በቀላሉ ወደዚህ ጋር በማምጣት ምን ማለት እንችላለን? Possible that V total means, so we say that V total is equals to V1 plus V2 plus V3 plus V4, where V1, V2, V3 are said to be the total electric or the electric potential that is dropped through each capacitors. So what does it mean V total? It seems like Q total over V total which is equals to Q1 over very possible that C total, where this one is C1 plus Q2 over C2 plus Q3 over C3 plus Q4 over C4. This is the way how we are going to finding the total electric potential. But the value of Q1, Q2, Q3, Q4 are the same because the charge is constant when the combination is series. So it is possible that Q total over C total is equals to, instead to write Q1, Q2, Q3, Q4, we are going to take the value of Q total. So Q total over C1 plus Q total over C2 plus Q total over C3 plus Q total over C4 is possible. So using the mathematical expression, it means that Q total over C total is equals to, a possible that what? Q total into 1 over C1 plus 1 over C2, 1 over C3 plus 1 over C4 is possible. So it is possible to cancel out by Q total is cancelled out by Q total. The remaining one is 1 over C total is equals to 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C4 up to 1 over Cn. This is always true. where C1, C2, C3, C4 up to Cn are connected in what? In series. Combination ናቸው series የሚሆን ከሆነ በቀላሉ በእንደዚህ አይነት መልኩ ማስላትና መስራት እንችላለን ማለት ነው። So how we are going to do if the capacitors are combining in parallel combination ቢሆንስ ማለት capacitors in parallel. Let's solve different expression regarding with this expression. So look at, if the capacitors are combining like this, here it's possible that C1, C2, C3, here all of the capacitors are combining in parallel. So here you have a source, positive terminal, then negative terminal. This is the way the electric current is flow through the circuits. So in case we can say that the total electric potential that is dropped through each capacitor is the same. That means V1 which is equals to V2 which is equals to V3. It is possible that it is what? It is constant. Constant. The second expression is about the charge. Q total is equals to Q1 plus, Q2 plus, Q3. This is how we are going to just finding the value of what? The charge that is stored through the circuits. But it's possible that the total capacitance of capacitor is equal to the total charge divided by its total electric potential. Total electric potential is possible. Then let's find the value of Q totals. So Q total is equals to C total times V total. Instead, let's replace. So Q total which is equals to Q1 plus, Q2 plus, Q3 is possible. Instead, to write this Q total, we are going to substitute what? C total, V total, which is equals to, instead to write this Q1, we are going to write C1, V1 plus. Here again, instead of Q2, we are going to substitute what? C2, V2 plus. Instead Q3, we are going to take C3, V3. This is the way how we are going to just expand to finding the total capacitance of capacitor. But it is possible that V total is equals to V1, which is equals to V2, which is equals to V3. So let's say that C total, V total, which is equals to C1, V total plus C2, V total plus C3, V total. So it is possible that C total, V total, which is equals to, instead, let's take as a common V total, so C1 plus, C2 plus, C3. So the voltage are cancelling together. The remaining one is what? The total capacitance of capacitor is equals to C1 plus, C2 plus, C3. This is the way how we are going to finding the capacitance of capacitor in case of what? In case of parallel. When the capacitors are combining in parallel, we are going to just prove the statement like this. This is all about today's lesson regarding with the way how we are going to combining capacitors in series as well as in parallel. And rather to expressing or narrating the formula, we are going to just driving as you can just observe. ከዚህ በፊት ፎርሙላው ይሄ ነው ፎርሙላውን በእንደዚህ አይነት መልኩ ተጠቀሙ ይላል ፎርሙላ ነበር የምንነግራችሁ ዛሬ እንግዲህ በዛሬው ትምህርት ውስጥ ምንድነው ያደረኩትኝ በቀላሉ ለካፓሲተንስ ኦፍ ካፓሲተርስ የምንጠቀማቸውን ፎርሙላዎች ድራይቭድ በማድረግ በቀላሉ በየትኛውም የጥያቄ ሂደቶች ውስጥ ካፓሲተንስ ኦፍ ካፓሲተርን ወይም ደግሞ ቶታል ካፓሲተንስ ኦፍ ካፓሲተርን ኢኩዌት ለማድረግ ፎርሙላውን በቀላሉ በእንደዚህ አይነት መልኩ ተጠቅማችሁ ፕሮቭ ያደርጋችሁ መስራት የምትችሉ መሆኑን እና ዝም ብሎ የመጣ ብቻ ሳይሆን በቀላሉ እንደዚህ በምክንያታዊ በሆነ መልኩ እየሰራችሁ መረዳት ትችላላችሁ ማለት ነው። የዛሬው የትምህርታችን ርዕስ ይሄን ይመስል ነበር። እስከ መጨረሻ ስለተከታተላችሁ አመሰግናለሁ። የሌላኛው ቪዲዮ ላይ እስክንገናኝ ድረስ ሳንለያይ ሰብስክራይብ ማድረጋችሁ እንዳትረሱ።